Okay, so we're trying to prove things. Okay, so we're either trying to prove that like things are congruent, less than or greater than, or equal. Okay, all these things right here, this, that, and that, all of those things have to do with distance of stuff. Or like if you want to consider it, like if you want to think about it as length. Would you guys agree with that? Like if you want to show two things are congruent, that means they're like the same length, right? They're the same size, so you'd have to like make sure they're the same length, whatever. So if you're looking like BC and DC, so that's like this line and this line, to me, I feel like those are congruent. But to prove it, I'd have to actually find the length of BC, find the length of DC, and make sure they're the exact same thing. Does that make sense? So there should be in the first video in 8.1 we learned how to find a diagonal distance. Okay, so if I want to find the diagonal distance, we have to form an imaginary right triangle. We have to form that imaginary right triangle and then figure out what the legs are. And remember, the legs are always horizontal and vertical, so you can just count them. So like right here, how big is this leg of this imaginary right triangle? Kind of hard to tell with their grid. It's not the best. Think about the rectangular coordinate thing that we just did. This point B is up how much? 3, right? This point right here is up how much? 0, right? It's on the line. So to go from up 0 to up 3, how much did we go up? 3, right? This one over here starting at 0, and we move over to 4. So that's 4, right? It's just like what we did in the first one. Vertical distances, you just count the squares. Okay, I know they skip squares here, but that's why we do that thing on the last ready, set, go. We have to be able to adjust if they don't give us all the squares. Okay, so that's 3, that's 4. So now, to find the length of BC, we do leg squared plus leg squared equals hypotenuse squared. And the hypotenuse is the one we don't know. So if you solve that, that should give you BC. Alright, so the rest of them you kind of do that the same way. Use the distance formula, which is basically just making a right triangle and then finding the hypotenuse. So that's how that's what you're gonna be using in the proof for if you're using any of these symbols to fill in the answer. Okay, so like if you think these two are congruent, you put the congruent sign right here, and then you have to go do the distance formula to prove it. Okay, these two right here though, perpendicular and parallel. Okay, perpendicular lines, those are the 90-degree angles with the opposite reciprocal slopes. You guys remember that? So if you think two lines are perpendicular, you have to find the slope of one and the slope of the other, and they should be opposite reciprocals. So like an example, I don't even know if they ask you for this, but like this line here looks to be perpendicular to this line here to me, like my eyes tell me that. But if I wanted to prove it, I would have to find the slope of this line, find the slope of the other line, and they would have to be opposite reciprocals. And that would prove it. So we're trying to get like a little more towards like formally like justifying things. Okay, so not just like, oh, well, like it looks like it crosses at 90, so it's perpendicular. Now we have ways of actually proving it. Okay, what do the slopes of parallel lines look like? They're definitely not opposite reciprocals. They're the same, right? So if you think that two things are parallel and you're trying to justify that they're parallel, you find the slope of one, write down what it is. Find the slope of the other one, write down what it is. and they should be the same thing. So, whereas these four things here, the first things we talked about, distance, length. So you need to find how long the things are, show that they're all the same length, if they're congruent or equal, whatever. These two have to do with slopes. So if you're claiming that something is one of these two things, the justification should involve you showing what the slopes are.